So, welcome back, students, in our chapter number 16, reflection of light. In earlier class, we have all have seen the laws of reflection. There are 3 laws of reflection. The angle of reflection is always equal to angle of incidence. The incident ray, the reflected ray, and the normal lie in the same plane. The incident ray and the reflected ray are on the opposite sides of the normal. These are the 3 laws of reflection that we have seen. According to this law, whenever reflection takes place from a smooth surface, this is a smooth surface that I have drawn. Okay, it is noted down that when reflection takes place and an imaginary normal is drawn, the angle of incidence is always equal to angle of reflection. Based on this, an experiment also can be performed if angle I is 50 degrees. In that case, angle R is also going to be 30 degrees only. So, always for a smooth surface, angle I is equal to angle R. Angle of incidence is equal to angle of reflection. Okay? But, if we are going to consider a rough surface, this is a rough surface, just like our roads on which we travel with our bicycle and other vehicles. In such cases, you see, in irregular surfaces, reflection of light will not be as it was on a smooth surface. So today we are going to see difference between the reflections of a smooth surface and a rough surface. You see, what is the relationship between the angle of incidence and angle of reflection? For a smooth surface, they are always equal. But if we are going to change the surface, if we are going to take a rough surface, you will find that the incident rays will definitely fall as they were on any smooth surface, but the reflections will go haphazardly anywhere. Can you see the 3 rays I have drawn? This is the incident ray, and incident ray. The reflected ray are not going to be regular. They were scattered in varied directions depending upon the ditch or the irregular part where they were incident upon. So, rays that fall on the smooth surface will be parallel to each other on reflection. You see, these rays which are parallel to the incident ray will also be parallel with the reflected ray here. Can you see? But here, when the 3 incident rays were parallel and they fell on the rough surface, they got scattered in varied direction. They were not parallel to each other. So, first of all, let us consider the regular reflection of light. The reflection of light from a plane and smooth surface is called as regular reflection of light. For regular reflection, the angles of incidence as well as angle of reflection are the same for all the parallel rays falling on that surface. Thus, the reflected rays are also parallel to one another. If the angle of incidence for incident ray is I1, I2, if we consider that way, and the angle of reflections we consider R1, R2. Here, as we are going to consider more than one rays, this will be angle I, angle R, angle 1, I1, I2, R1, R2. You see, they are going to be parallel to each other. And one more thing, their angles of reflection, we can consider will be the same. So, I1 is going to be equal to I2 and I3, such like that. And these are also equal to, they are all going to be equal to R1, R2, R3 also. As per our consideration, we are taking 2. So, angle I equal to angle of incidence 2 will be equal to angle of reflection 1 will be equal to angle of reflection 2. That way, it will move on. As many we are going to consider, that many will be equal to each other. Okay? Because the reflection has taken place from a smooth surface. But if we are going to consider an irregular surface, this rough surface, reflection of light from a rough surface, we call it as an irregular reflection of light. In irregular reflection, the angles of incidence of parallel rays of incident are not equal, and therefore their angles of reflection are also not going to be equal. So here how you are going to write down is angle of incidence 1 is not going to be equal to angle of incidence 2 is not going to be angle of incidence 3. Not a single angle is going to be same. In that same case, angle of reflection are also not going to be the same. Will be equal to angle of reflection 1 is not equal to angle of reflection 2 is not equal to angle of reflection 3. This is the condition for a rough surface, and for a smooth surface they are all going to be equal. So we can say that this is irregular type of reflection, and for a smooth surface it had regular reflection. This way we can write down difference between regular reflection of light and irregular reflection of light. Thus the reflected rays in this case is not parallel to one another and spread over a large surface. This is clear from this figure that you can see on the board. So what we need to remember, what we need to learn, we should be able to differentiate between regular reflection and irregular reflection of light. Okay? And laws of reflection are followed. Very important thing to note down. Laws of reflection that we have studied, that are followed in both regular as well as irregular reflection. And the reflection of light in irregular reflection has not been obtained because the laws of reflection are not followed, but they are obtained because the surface is rough. Only due to the rough surface, laws cannot be properly accepted in case of rough surface. And in irregular reflection, the angles of incidence at different points are different. But at any one point, the angle of incidence and angle of reflection are equal there also. Okay, even if it is scattered in a different way, angle I will be equal to angle R, but because of the rough surface, they are not parallel to each other. They are scattered over a large area. Okay. And reflection of reflected light. You see, what type of image do we see in a mirror? Is it exactly the same? Of course it is, but it is laterally inverted. You know lateral inversion? The right hand of the body. If you raise your right hand, in the image, left hand will be seen to be raised. Okay? So, right and left side are laterally inverted in the mirror. Okay? And how do we see the image of the moon in water? On a full moon day, you can get the image of the moon in water also. There also we find the same thing. And in case of when you go and visit a barber at a salon, you had a haircut, and if your neck properly have to keep, in that case, on the back side, the type of haircut can be seen with the help of another mirror that is kept at the back. In saloon, there are mirrors in your front as well as in the back side. The image of the back of your head is formed in the mirror at the back. And the image of this image is formed in the mirror in front of you. And thus you can see how the hair at the back side of your head is being cut. Are they in steps or any other pattern? Isn't it? So you see, from mirror to mirror, image is copied down. Now, for moon in water, as moon is not self-illuminous, it is not having light of its own like the sun. Okay, the sunlight falling on the surface of the moon is being reflected from the surface of the moon. This reflected light is again reflected by the water to give us the image of the moon. In this way, light can be reflected several times from one thing to another, from another thing to the third thing. So, light can be reflected not only from the luminous object, but the object that is reflecting it is again and again reflected. Okay. So that we need to understand. Next thing, yeah, you can make this at home also. A kaleidoscope and a periscope are the two instruments we can make, and we can understand the laws of reflection, the light, how reflected ray, and in the mirror, how multiple images are also being formed. So what we can do to make up a kaleidoscope, we can take 3 rectangular mirrors. What we need is 3 rectangular small mirrors. And we stick it with a cello tape or any other sticking tape in a triangular form, and we can make a triangular pipe. A triangular pipe can be made out of these 3 triangular mirrors, and they can be fitted in a triangular way. What we can do is white paper of triangular shape and fix it with tape at one end of the mirror's closing. One end we are going to close it and we can insert some small glass pieces in it, and from the another end we can keep one hollow and observe through that. Okay, now we can see different designs in the kaleidoscope. The colorful mirror, small pieces of glass are making colorful designs inside the kaleidoscope. The speciality of the kaleidoscope is that the designs do not easily repeat themselves. Every time the design is different, and people make wallpapers which are used to decorate walls, and cloth designers also use a kaleidoscope to get new designs from it. Okay, variety of designs can be perceived from this kaleidoscope. So it has uses also. Wall designs or cloth print designs can be made out of these kaleidoscope designs that we can observe. Then another instrument that we have where we are going to use this reflection process is a periscope. Now you see, in periscope we have to take a long pipe and the lower end will be opening in one direction and the upper end will be opening on the other direction. See, from here we can observe with the help of our eyes, and from here we can see something at a height. Okay, but the thing is we need to put up mirrors here, plain mirrors in tilted form, slanting form. Two mirrors we have to fit over here when we put this side pipe. Okay, and whatever is at the height will be putting a image on this first mirror. The image of that will be again formed on the second mirror, and this image will be perceived by us with the help of eyes. Okay, this type of periscope, this periscope is a very useful instrument if we are in a submarine in the ocean floor. Then also with the help of periscope, a long periscope, we can observe what's going on above the ocean floor. So military people, Navy ones, they are utilizing this periscope to observe things which are at a height from their level. Even in the mountainous regions, periscopes are of great use. Okay, and we can observe from there. From the bottom window, one can see what is in front on the top window in periscope. This device, very well known as periscope, is used in submarine to see objects above the surface of water. It is also used to observe and keep a watch on the objects or persons on the ground from an underground bunker. Bunker, have you heard this? It's also an instrument, space where military people can hide themselves inside the soil. It is being made to protect them from the enemy, and they can keep a watch on the enemy movements on the borders. We all, if you all are watching the news nowadays, what's going on the border, Indo-China border or Indo-Pakistan border, all these things, instruments are of great use. So kaleidoscope and periscope both are used in different ways, and the property of reflection is only used in both these instruments. So you can try making a kaleidoscope and a periscope at home also. And the next class we shall see how to solve the question answers related to this reflection of light. Okay, so bye all of you.